Good day to all. Today we are going to see about that speed control of DC motors. The main content in that factors affecting the speed control of DC motors and the different types of speed control of DC and DC shunt motors. Then what Leonard Lear system of speed control. Then we'll see one by one. First, factors affecting the speed of that DC motor. These are all the factors affecting the speed of the DC motor. First one is the flux and voltage across the armature and applied voltage. Then, depending upon these factors, the various methods of speed can be controlled. See, depending upon these factors, first one is changing the flux. If changing the flux, controlling by the current through the field winding called the flux control methods. Then changing the armature path resistance, which turns the change the voltage applied across the armature called rheostat control. Then changes the apply voltage is called voltage control method. See, if we are changing the flux, then it is called a flux control method. If you are changing the armature part of the resistance, then we will call that rheostat control. If we will change the voltage, then it is called voltage control method. This is the speed control of DC shunt motor. First one is flux control method. First you will see the diagram. See here in the flux control, here the motor is connected with this rheostat, and near that rheostat one field winding is connected. The voltage supply is given here. See, this is the shunt motor. If you are seeing here, in that motor you have armature A1 and A2. See how we can control the speed over here. If you are giving to the power supply, then it will start rotating. From this rheostat, we will have a adjustment of from this resistor. Depending upon this resistor, we will control over the speed of that flux. So the flux is the speed. With that flux we will control the speed of this motor. That's why we can call this as a flux control method. If you are seeing the graph of this flux control method, you will see here N is a speed and I is a current. The speed may decrease with increases in the current. Here if the current is increases, the speed is decreases. Likewise will happen in that flux control method. It is a DC shunt motor. This is the armature voltage control method. See here we will give a supply to that motor, but this winding, this resistor directly connected with that armature. But here this supply is as it is, but here this resistance is directly connected with that armature. If you are giving the supply, then power will flow from here. With this adjustment of input power supply, we will get the controlling the speed of that particular armature voltage. If you are seeing this graph also, here the speed versus voltage, it is speed normally rated, normal speed, then it will become the below normal. So with the adjustment of that input power supply, we will get the control of this motor. So here we'll control the armature voltage, so it is called that armature voltage control. Then this is the potential divider control. See here the motor is connected with the potential divider, whereas in previous we'll connected with the resistance, and here we'll connected with the potential difference divider. If you are giving to the power supply, then the current will flows from here and there. This field winding gets connected as well as this motor get running. If you are give the adjustment to this resistance, according to these adjustments, we will have a control of the speed of this motor. This is the curve for that potential divider control method. The ends states that here is the speed and V is the voltage. See here, voltage is initially it's in resist position. After some time only it will get rises. This is called voltage required to overcome inertia or friction. We can simply say it's for IA and RA drop. This is the potential divider control method. Then the applied voltage control method. See here, we are giving the three-phase supply over here for that field winding. Then this armature winding is connected for another supply. The thing is, if we are giving the 440 volt, if you are giving to this 0 volt and 220 volt means this connection will go here and this connection will come here. Accordingly, we will change connection of this motor. From that easily we can control the speed of that particular motor. And see here, this is the flush control of shunt motor. It is also having series motor also, where the connection will be in series. See, this is this flux control is in shunt type because the connection is in shunt, whereas we'll have a series motor also. See where it is motor is there and this A1 and AB is there. Then this resistor with seriously connected with that field winding. Then we'll give the supply. We'll give the supply over here. With the help of this changes in that input, we will get control to that flux control. That is the DC series motor method. Then we will move up to that another control method, that is the flux control field divider method. See here also is the same thing. If you are seeing here, the input power supply is given to that series winding. This series winding is given to that motor, but the thing is after winding the connection will go up to that resistor, as well as current will get deviated from here. See, if you are giving the power supply to this circuit, the current IL flows here in this winding and flows here also in this RX winding also. So it will get deviated here. The series field winding is shunted by the variable resistance RX known as field divider. We can say here it is this RS is a field divider, and this speed control is above rated value of the motor. If you are seeing the graph, you can see speed N and speed versus current characteristics will have graph like this. If the speed is decreases, current is increases, with the RX is decreasing. So it will have some divider over here. With that we'll have a current deviation. From that we can vary this speed of that motor. That's all. Thank you.